Alright, so today we're going to be working on this Algebra stacks. I've got Screencastify running, and I'm recording on here, so I'll be looking at my screen, and hopefully everything comes out. Had a little bit of trouble getting set, but I think we're ready. So, Algebra stacks series, this is quick, try to get you guys everything you need right away, the details. How to graph like a boss. No, that's not working. Need something else. Let me know what you got. So here's an example of what your first note card is going to look like. We're going to run through each individual page in a second. So just things that we're going to continue to focus on is slope-intercept form. That's an equation that lets you graph a line. This concept of slope, this idea of rate of change, linearity. Y-intercepts, you know, where does the graph cross the y-axis when x is 0. So slope-intercept form, you got to know that, you know, y equals mx plus b. That's something that most people remember. It sticks with them. And a slope represented by m, and m is always attached to x because you multiply the slope by the x. So how much you get paid per hour is times by the number of hours. How many miles per hour you're going is times by the number of hours. If you get into more sciencey stuff like physics, there's a lot of really good application stuff there. And y-intercept, consider that, I don't like saying starting value, but in real life situations it usually is. Like, for example, if you have $500 in the bank and now you're starting to work a job that's going to pay you 10 bucks an hour, hopefully 15 soon, how much money would you make after working 100 hours or whatever? You could figure it out that way or graph it. Remember that y-intercept is represented with 0, b. It's when x is 0, it's x, y, x, y. Get that in there. I think I'm going to have to use the touchscreen on this. I don't think I like this, but an order pair is always x, y. What else we got? Rise over run. Rise, up or down. Run, left to right. It's like you're reading a book. You got to get up and get that money, and then we go that way. Go to the right. This is my right. I don't know if that's your right. Rise over run, changing it, y over changing x. That's another slope. Every number you can divide by 1. So in this equation, y equals 5x plus 8. 5 is the slope, 5 is the m. And it's a positive slope, and it says you're going to go up 5 and over 1. Y-intercept is 8, 0, 8. In this equation, you don't see a number in front of the x, but remember that there's still one x, that's the coefficient. So the slope would be 1, which can be written as 1 over 1. You go up 1, over 1, up 1, over 1. And the y-intercept is negative 3. In this case, it's a negative x, that's a negative 1, which is a negative slope. Is going down from left to right, not up. Got the y-intercepts. Let me know if you have any questions about that. Let's get my eraser tool. Clean this up. Alright. So graphing slope-intercept form. This is like the most commonly used graphing equation. It's the most straightforward. And the first step is just plotting your y-intercept. So the y-intercept, you find the y-axis where x is 0, and you plot that first point. So if it's a positive number, it's above the equator, if you will. We did a geography quiz, Kahoot earlier. So I think a way to remember it, equator is your horizontal, your x-axis, and your prime meridian is your vertical, your y-axis, if you're into geography. And then you graph using slope. Slope tells you the direction and steepness of your line. So it's going to tell you how much to go up or down, and then how much to go to the right. And then connect your points. You need at least 2 points. You get a straight edge, a ruler, something. Extend that line out. We don't want no T-Rex graphs. Arrows on the end because the lines go on forever. Sadly, your relationships don't. So in this equation example, we got 3x plus 4, and the y-intercept is 4 because the 4 is the constant. If you just get a constant number in this equation, it's going to be your y-intercept. Y equals a number. That's your y-intercept. That's your y-intercept. So on a coordinate, this is quadrant 1. You see quadrant 1, 2, 3, 4. 0, 4 is your y-intercept. You plot that first, if you have it, which in slope-intercept form you have to. The slope is m is 3, so that's going to be rewritten as 3 over 1 to give us our rise. We're going to get up 3 and go 1 to the right, up 3, right 1, up 3, right 1. Plot a point there. From your y-intercept, some of you guys like to start down here at 0, 0 all the time, and that's just not it. You got to start at the y-intercept and then go up 3 over 1, plot that point. And you could keep doing that. You can go up 3 over 1, up 3 over 1. Now, if you wanted to, you can go from the y-intercept, you can go down 3, left 1. You can do the opposite. That works too. So we plot that point at 1, 7. Get your ruler, get your straight edge, graph that line. And now you have a positive slope line. You can continue to track it. You could go all the way to x is 10, x is 20, x is 100, and see what happens with whatever situation this applies to. So it's going to be the other part of the note card. We got point slope form. So these are the different forms. So you had slope intercept form, which is the most common, and now we have point slope form. Now, math people aren't that clever. So slope intercept form had a slope and a y-intercept. Point slope form has a point and a slope. Pretty straightforward. So let's get into it. And again, I totally could see this being used for you in an index card form. If you need a little more room, you could do like a Cornell Notes style. Just have this as a quick reference sheet to help you get through your graphing. So point slope form. Y minus y1. Y1 is the y coordinate of the point you have. Equals, oh yeah, we're repping case today, by the way. Missing you guys. Equals m, slope, x times the quantity, x minus x1, where x1 is the point. So x1, y1 is the point, m is the slope, and you'll see what that means in a second. So the point on the graph is very important. It doesn't have to be the y-intercept. It can be any point on your line. See all those lights in my glasses? And then m is the slope of that line. So we got your rise over run. We already know this. Now in this equation, you're not given slope-intercept form. You don't know the y-intercept. So you have to find out what x1, y1 is. So we know the slope. Slope is m. M is going to be multiplied by that x minus x1 every time. Identify slope first. It's important. I don't like how this is set up. Hang on. Let me get this mouse away. So in the next example, you have another equation. Again, look for slope first. So it's y plus 7 equals x minus 3. You're like, but there's no parentheses. Sometimes that distribution, the multiplication already happens. So if it's not in y equals form, it's probably in point slope form. It could also be in standard, which we'll talk about, but you got to look for it. So they are showing you two equivalent equations there, and the slope is still 1. Now, we know that's got to be written in rise over run. Always do that. I do it. I'm really good at math. I've been doing this for a long time, and it just helps me keep everything straight. Same thing in this example. This is going back to that one we talked about for slope-intercept. It just has a negative slope this time, a -1 slope. Okay, so this is the important part. Now, if you're looking here with the x1 and y1, you'll notice in the equation it's written as y minus y1 and x minus x1, or a negative y1, a negative x1. It's written that way, and you always have to know the x1 and the y1 that the points have, the coordinates have, are always going to be the opposite of what you see. So in this case, it's y minus 2. It's always supposed to be written as -2. So really, the y1 is 2. It's not -2. It's not a -2. It's 2 because you're subtracting what y1 is. So y1 really is 2. This is a big thing that people get wrong, and this follows you when you get into transformation of the functions and your quadratic functions and all that stuff next year in Algebra 2. So, and graphing circles. So please make sure you get this, that in this situation when it's written like this, you're looking for the opposite. Same thing for the x. It's x minus x1. Now you see x plus 8. The only way to get a plus when you're minusing is if you're subtracting a negative. You subtract a negative, you add the opposite. So that's really a -8. So the ordered pair, the point that you're given is -8, 2. That's given to you from the equation. So you would start by plotting that point. That's your point that you're given on your graph. Oh, let's go back to the mouse. So in this example, we see that it's y plus 7. That means you're looking for the opposite of that, which is a negative 7. Excuse me. I have to edit this out for a second. So you have the plus, the minus 7 for the y one, and then for the x one, it's going to be a positive 3 because it's the opposite of a negative 3. So the point you're given is 3 comma negative 7. You also are given the slope, point slope form. Let's get that eraser tool real quick. I gotta learn these shortcuts for Screencastify. So graphing, step 1. Graph that first point. You got an x and a y, x comma y. You got the ordered pair. Plot that point. It could be on the quadrant 1. It could be in quadrant 3. It could be anywhere. It doesn't matter. That's the point you have on the graph. That's your starting point in this situation. Slope tells you the direction and the steepness of the line. Do what it tells you to do. Connect your points. So you have the example. Y plus 2 should be triggering already. Y1 is going to be negative. The slope is negative 2/3, so we're going down 2 to the right 3. X minus 6, so we're looking at a positive 6 as x1. So your coordinate is 6 comma negative 2. That's the point you're given for this line. Plot it. Boom. Looks like we're in quadrant 4. 1, 2, 3, 4. Then slope's negative 2 over 3. So we're going to go down 2 and over 3. Do that. Down 2 over 3. Plot that point. Plot that next point. You have 2 points on your graph. Get your straight edge, get your ruler, extend that line out. There you go. You graph the line in point slope form. Point, slope. Do it. Standard form's the other one. Standard form, what can I say about standard form? It's not really used too often in specific like math problems. You will come across it. I think the biggest thing you need to know about standard form is just if it's not in slope-intercept form, you can always solve to put it in slope-intercept form. Even those point-slope form equations, you can solve them for y. So that's the big takeaway. Remember, solving literal equations, solve for y. If you solve for y, you can get it in slope-intercept form, find the y-intercept, find the slope, and graph. So here we have 5x minus 4y equals 20. So this is what your whole sheet's going to look like. We're going through each individual one. So if you see something like that, tell yourself, okay, I can solve for y. So standard form, ax plus by equals c. A and b are coefficients, c is a constant. Okay, so we're going to, I don't like, I should have changed this. I don't like cross off. But basically, you're going to make, yeah, I can't watch this. So hang on, let me fix this real quick. So instead of the word cross off, what we're really doing is we're substituting 0. We're zeroing out the y. So 5x minus 4 times 0 equals 20. Now you know anything times 0 is 0, and that's where that whole x off, cross off comes from. That's bad math language. I didn't catch it when I was looking at this, my bad. So cross off just means substitute 0. You can do that. You can zero out y to find the x. So we're trying to find the x-intercept. Now remember, x-axis horizontal to the equator. When you have the x-intercept, it's just when y is 0, what the x value is. We already know how to find y-intercept. So in step 2, that's what they're saying. Instead of crossing off ax, you're really making x 0. We're making x 0. So they graph the x-intercept right there, 4, 0. We're making x 0 for step 2 to find the y-intercept. Solve the equation. You get y equals negative 5. So now you know your x-intercept and you know your y-intercept. That's 2 points. And we already know to graph a line, you only need 2 points. So this is another way to graph is by finding the intercepts. If you don't want to go ahead and solve the whole thing for y, that's my preferred method. Okay, so on this one, again, this probably isn't super clear. I had a pivot on here with this whole cross off. Cross off just means you're plugging in x. There you go. So the other way to do this, let me backtrack real quick. just go right here. So the other way to solve a standard form equation and graph it would be to solve for y. So if you get the equation, let's see if I can get this pen to work a little better for me. 5x minus 4y equals 20. That's an equation. You can solve it. You can solve any equation. So I'm going to go ahead and I'm going to train track this. I'm going to solve for y. So I'm going to subtract 5x on both sides. Subtract 5x on both sides. Get negative 4y equals, please, please, please do not write something like 15 or 15x. 20 is a constant, 5x is a variable. You cannot combine unlike terms. So do not do that. It's just going to be written as 20 minus 5x. And then to get the y by itself, you divide by negative 4. And you get y equals, divide each term on the right hand side by negative 4, so you get negative 5. And then a negative 5 divided by negative 4 is a positive 5 over 4x. This is written in, this is written in slope-intercept form. You have the m, which is 5 over 4, and you have the b, which is negative 5. You can go ahead, plot that y-intercept, do what slope says, go up 5 over 4, and get that line. So again, stack series, I'm just trying to get you guys as much content as I can. If something didn't make sense, you want me to go, please let me know. I'm going to make as many of these as I can. Stay safe out there. Let me know what you need. Subscribe, share me out. I'm doing good work out here, trying to help you guys learn some math. Share the love. I'll see you guys later.